So yesterday we started talking about absolute value equations. What I'd like to do today is put together a formal list of steps and talk about how sometimes there is going to be no solution for an absolute value equation. The first step is always to isolate the absolute value. In the end, you always want the absolute value on one side and a number on the other side. Step 2 is to break up the problem and make two separate problems. When you do this, you don't need the absolute value symbol anymore. Next, after you have two separate problems, you solve each equation separately. Finally, if the absolute value is ever equal to a negative number, your answer is no solution. The reason is because when you take the absolute value of something and you equal a negative number, that is impossible. An absolute value is always going to give you a positive number. Now, you can only make this determination after you have isolated the absolute value. So we'll look at an example that works out like that in a second. For example, the first thing I would do here is isolate the absolute value. So I would add 5 on both sides. I would get 3 times the absolute value of 2x minus 7 equals 9. And then I would divide by 3 on both sides, and I would get the absolute value of 2x minus 7 equals 3. Now you'll notice here that this number is a positive number. As long as this number is a positive number, you're going to have two solutions. So if you isolate the absolute value and you equal a positive number, there are two solutions. From here, I'm going to break this up and make two separate problems. So I'm going to have 2x minus 7 equals 3 and 2x minus 7 equals negative 3. Then I'm going to solve each problem separately. In this first problem, I would add the 7. I get 2x equals 10, and I would divide by 2, which means x equals 5. In the second problem, I would add the 7, which means I get 2x equals 4, and I would divide by 2, which means x equals 2. Now, what is it going to look like when we should say that the problem has no solution? So let's look at an example. In this example, we again need to isolate the absolute value. So we're going to add 5 on both sides, and we get negative 3 times the absolute value of 2x minus 7 equals 9. Then we're going to divide by negative 3 on both sides. When we do that, we get the absolute value of 2x minus 7 equals negative 3. This time, you'll notice we got a negative number here. When you get a negative number, you can't do this problem because an absolute value answer is always a positive number. So you would say no solution. So how are we going to know when we should say no solution? When the absolute value is isolated and it is equal to a negative number, we say no solution. Let's look at some examples. All right, so problem 1. First step, isolate the absolute value. So in this problem, that means I need to subtract 6 on both sides, which means I get the absolute value of 3x plus 5 equals negative 8. Now right away, I go, uh-oh, this is a negative number. Therefore, the answer is no solution, and I'm done. I like these problems, nice and short. Let's try another one. Number 2. I would draw my line. I'm going to subtract 4 on both sides. So I get 2 times the absolute value of m minus 5 equals negative 2. Then you divide by 2 on both sides, and you get the absolute value of m minus 5 equals negative 1. Once again, I go, uh-oh, this is a negative number. So the answer here would be no solution. Now, I will tell you that one mistake that students often make is that they try to determine whether there is no solution or not too soon. So, for example, in number 3, some students look at number 3 and go, oh, this is a negative number, there must be no solution. But they haven't gotten the absolute value isolated yet, which means they're actually going to get this problem wrong. Watch what happens when we isolate the absolute value. I'm going to add 7 on both sides, so I get negative 3 times the absolute value of n plus 2 equals negative 3. Then, when I divide by negative 3, a negative divided by a negative makes a positive. It turns out that by rearranging the equation a little bit, we actually do end up with a positive number. So now I can break it up and make 2 separate equations. So step 2 is that we make 2 separate problems. N plus 2 equals 1, and n plus 2 equals negative 1. And now we solve. So we would subtract the 2 on both sides and get n equals negative 1. Subtract the 2 on both sides and get n equals negative 3, and we're done. This is an example where students often get this problem wrong simply because they don't bother to isolate the absolute value before making a decision about whether or not there are solutions. Let's look at number 4. Number 4, if I just looked at it first glance, I might go, hey, there's a negative, there's no solution. But when I isolate the absolute value, so when I add 4 on both sides, I get the absolute value of x plus 3 equals 3. It turns out that I get a positive number when I do that rearranging, which means I actually need to write 2 equations. X plus 3 equals 3. X plus 3 equals negative 3. So I'm going to subtract 3 on both sides, which means x equals 0. And I'm going to subtract 3 on both sides, and I get x equals negative 6. Let's go ahead and turn the page. We'll try like one more example. So maybe we'll do let's do number 8. Number 8 is a good example of when we need to isolate an absolute value by multiplying or dividing. So at first glance, I might go, oh, it's equal to a negative number, there must be no solution. But if I isolate the absolute value, which means if I divide by negative 3, I get that the absolute value of 4x plus 3 would equal positive 3. Now, because 2 negatives make a positive. So if I break this up and I make 2 equations, I get 4x plus 3 equals 3, 4x plus 3 equals negative 3. Now I'm going to subtract the 3 on both sides, so 4x equals 0. Subtract the 3 on both sides, so 4x equals negative 6. And I'm going to divide by 4 on both sides, so x equals 0. Divide by 4 on both sides, x equals negative 3 over 2, or you could change that to negative 1.5. I would accept either one of those answers. And we're done. I hope this makes sense. We will practice this some more tomorrow, and I will see you then.